Hello class, welcome to our lesson for today. This is in section 1.4, dealing with collecting sample data. We're going to go through a lot of different terms and some different pieces dealing with how to collect sample data today. So there'll be a lot of different terminology that you want to make sure you're keeping track of as we go through today's lesson. The first thing about statistics is where is the source of the data? So there's two main options. One is observational study and the other is an experiment. The key is, did you assign some type of treatment to some group of the subjects? So an experiment is when you apply that treatment to one part of the group and then observe the effects that it happens. If that can be done, that would be better for statistics because you can kind of see what the difference between with treatment or without treatment, for example, of a study. That being said, sometimes you're not able to do an experiment and you just have to observe what's happening, which is obviously what an observational study would be. Okay, you're able to see kind of what's happening or what the characteristics of something are, but you're not able to actually put some type of treatment into one group or apply it in order to see the difference between the two. Okay, so for example here, this first one is a good example of an observational study. You have 3,400 adults and you ask them if they've smoked a cigarette in the past year. I'm just guessing you're probably not going to, it's probably frowned upon to force people to be able to, or to force people to smoke. So all you can do is observe the fact of if they have or have not. And so that's a good example of where an observational study would be necessary as opposed to an experiment. The second one, 5,000 people that have the flu are studied to see how long they recover. 2,500 are given an antibiotic. 2,500 are given some type of placebo or just it's nothing. Okay, that's an experiment because you're comparing the one group to the other and then seeing the difference in between them. Next thing is the difference between a random study and a random sample and a probability sample. Ideally, we'd like to have random samples where everyone in the population has an equal likelihood of being chosen. Oftentimes, that can't be the case, and we have to do what's known as a probability sample, where certain members of a group are more likely to be picked versus others. There's different ways that can happen, but essentially, it's either everyone has an equal likelihood of being chosen, or certain groups have a higher likelihood of being chosen. So for example, if I take the 1,000th light bulb taken off assembly line, that's a probability sample because not every light has the same chance of being chosen because the 1,000th one is being chosen. And we're actually going to get into these a little bit more detail. This type of probability sample has some other attributes that we're going to look at later on. Picking marbles out of a bag, that's just a random sample. Picking 2 of the 50 states. Picking 2 of the 50 states would be a random sample. However, if you survey people from each of those states, it's probability because each state has a different population. So our likelihood of being chosen in Indiana would be different than our neighboring states, okay, or any state in the United States, because of how many people live in that particular state. Roll 6-sided die twice. The key is twice. Add up the two numbers. That's a probability sample. If you've ever played Monopoly, you'll know that rolling a 7 is most likely to occur. But when you're looking at probability sampling, it's not the same likelihood to roll a 7 as opposed to a 2 or a 12. So that's why it's probability and not a random sample. If you played a junior version of Monopoly or a game like that that has 1 die, then that would be a random sample because anything with 1 die has the same likelihood of being chosen in any face that is rolled. Okay, the next one is kind of confusing. It often causes a lot of issues. I would just focus on the idea of a random sample, but a simple random sample says that every sample of size n, or whatever group you're trying to pick, always has the same likelihood of being chosen. Okay, so what it's basically saying is if you take any group that you want to sample, is it always equally likely that you get a similar group chosen? This is the most appropriate for statistics, and we're not going to go into too much detail. If you see something as random sampling, it's probably a good indication it's a simple random sample. I can get into a lot more details with that, but I don't know if it's necessary right now. So just remember, simple random sample is something that you want to make sure that you look at for statistics if possible. Okay, the other sampling methods that could be used. Number 1, systematic sampling. Systematic sampling is like the one with the light bulb, every 1,000th. Okay, select a starting point and then pick every so often of the population. So that's like picking every 1,000th light bulb off the line. A convenience sample is a sample that's easy to find. So often that can be something that's like a newspaper reporter goes out and talks to some people. That's just convenient. Okay, that's a version of a convenience sample. Stratified and cluster are similar, but they have very different attributes. A stratified sampling takes a group or a population and subdivides it into special categories, and then subjects in each category are then chosen as a sample from each group. So this could be something like race and ethnicity or income, those types of situations that are often like those survey questions at the end where you could answer them or you could not answer them. Those kind of group you into certain pieces. A year in school, freshman, sophomore, junior, senior is another example of that. And then you would sample from every group to see kind of what's happening. A cluster sample divides into subgroups, but you just randomly pick one of those groups, and that's what's known as a cluster because you're just picking one group of that and then select all of them to be able to make a sample. That could be done with classes, for example. If I were to take all my classes and then just ask one class what's happening, that would be a cluster sample, okay, in a way, because I'm only asking one of those groups, and I'm asking all of those people. Okay, so let's just kind of go through a few things about this and make sure we understand the difference between the groups. Reporter goes to downtown Indy, asks about a new city proposal. That's convenient. You're just going to Indy, you find some people, and you ask them a question. Surveying 25 girls, 25 boys about menu options. That's stratified because you split up the two groups, and then you've asked people from each group. Randomly select one of my 7th grade classes, survey how much homework they have. That's a cluster because I have multiple 7th grade classes, and I just choose one of them and ask all of them that question. Okay, so that's a slightly different version versus stratified as we're looking at a cluster sampling. Next one, set of ping pong balls. Blindly pick one of them. That's a simple random sample. That is not coincidentally why the Powerball and things like that with the lottery still use the ping pong ball idea, because it's the most random way to collect the data. All the ping pong balls have one number, do the vacuum thing, outspits one number, and that's still a simple random sample. I line up a group of 100 students, survey every 5th person. Okay, that's the idea of the assembly line. Okay, so you line everyone up, 1, 2, 3, 4, 5. Okay, many of you are having flashbacks to elementary school PE class or gym class when you tried to jostle your way to make sure you were with the right person and on the right team. But that would be a systematic sampling at that point. Okay, the next thing is dealing with observational studies. So everything we looked at before is hopefully looking at different groups. Okay, this is looking at how do I observe a study, a group of data, and when do I do that? Okay, so there's 3 main types. First one is cross-sectional. All the data is collected, observed, dealt with all at one point in time. That would be ideal if we could do that, but oftentimes it's not that way. So there's what's known as retrospective or case control, which is you collect data from the past by going back in time. Okay, a lot of things like that, for example, lead paint or asbestos, things that have harmful effects we didn't realize at the time. And so you go back and say, well, were you involved with that? I remember taking my boys to the doctor's office, and they ask, do you live at a place with lead paint? And I never really thought about it until that moment. Okay, and the answer was no, but they have to ask that question because they have observational studies from a retrospective case of dealing with that. And then there's also prospective or cohort. Those mean the same thing. The data is collected in the future from groups that share something in common now. Okay, so that could be something like I ask all of you some questions, and then 10 years from now we collect data about you because you're all West Lafayette students. So that could be a way of dealing with that scenario. Okay, a good example of a retrospective would be this first one. Physicians in Hawaii study senior citizens with hearing loss and determine if they were involved in World War II or not, because there's obviously some hearing loss correlation if you were involved in the war or not. So that would be going back in time and seeing if you were involved with something. Nielsen ratings, if you ever heard about that for things on television or finding ratings. So for the Super Bowl, you see the viewing habits of all of these families and televisions. That's cross-sectional because you're collecting all that at one moment in time and then seeing what the rating would be for that observational study. Okay, this next one says you're getting reactions on a judicial ruling. 200 men, 200 women were randomly selected. Assuming that the number of men and women are the same, which is the key part to this, is this a simple random, is it a random sample? And the answer is yes. Okay, because, first off, it's random because they say you randomly selected things. Now, this is a stratified sample because the men and women are separated. However, because the number of men and women are equal, every single person is equally likely to be chosen. For example, if there were 100 men and 1,000 men, 200 out of the 1,000 would be similar to the 1,000 women, 200 out of 1,000. So because of the statement that says the number of men and women are equal, or at least close to the same amount, okay, that also is a simple random sample. Again, I wouldn't get too hung up on that right now. Knowing the other versions is probably more helpful at this time. But remember, a random sample is what we want when it comes to collecting data for any type of experiment. Okay, teacher conducts a survey in the class, writes down, everyone writes if they're left or right-handed. This is a convenient sample because you're just sitting in front of me. I say, who's left-handed? Everyone raise their hand. Is this result probably typical of the population? The answer is yes, most likely, because this is a random sample, because being left or right-handed is kind of irrelevant for a classroom unless we're having like a left-hander society meeting, okay, or something like that. So when you're dealing with the left or right-handed idea, that's a pretty random piece of information to ask someone about. That would be similar to eye color or hair color. So it's probably okay. Is it a good method for collecting data? Probably not the best, okay, because we would like to kind of come up with a number in a more random situation or random way, like a number generator. But in this case, because the data being collected, it's such a random piece of information, it's probably an okay idea to have a convenient sample at that case, which is oftentimes why things like the news can do things like that, because a random sample can still be found even though it could be convenient. So those are some things to think about with this scenario. Okay, that's the end of our first day's lesson dealing with collecting sample data. Make sure you look at all the terms. I would probably write some things out with each of those. You're going to have to make sure you understand what each of those are dealing with as we move forward in the semester. Have a good day, everyone.